Hi, today we will be doing a question that requires the knowledge of lines and planes. Find the equation of the plane containing the line. This is the line and is perpendicular to the plane containing these two lines. Now this is the plane that contains these two lines. Alright, these are the two lines. Now you want a plane that is perpendicular to it. Alright, so this is the required plane. Right, this is perpendicular, and this is the line that is on this plane, the one that is in pink. So you are asked to determine the equation of this line. Now, what we can do is, if we do a cross product of the direction vector of these two lines, you will get a vector that is normal to this plane, normal to the plane that contains the two lines. So let's say you get a normal like that. Alright. You find that this normal is also parallel to this plane. Now you have a line on a plane and another direction, a vector that is parallel to the plane. You can the plane is already defined, so you can get the equation of the plane. So let us do the cross product of these two direction vector. 3, 4, 2, cross 4, 2, 3. Now this, the denominator, when it's written in the Cartesian form, the denominator is always the direction vector. Okay? When it's written is this form. So you cross the, let's work out the j component first. So this is 12, 12 minus 4 is 8, 8i. Then the j, so this is 9, 9 minus 8, so it's 1, 1, then you got minus outside, so it's minus j. Then let's do the k component. So this is 12 minus 16. No, 6 minus 16. 6 minus 16 you get minus 10. So this is minus 10k. Okay? So if we write it in column vector will be 8 minus 1 minus 10. Now if you want to write the equation in a vector equation on the plane, you are almost there already. So the plane, let's say we call it pi 1, alright, will be equals to, now A, just do a recap, plus alpha B plus, gamma B plus alpha, lambda C, sorry. Now, this is a point that is on the plane. And these are two vectors that are parallel to the plane. That is the vector equation of a plane. Now, this plane passes through 0, 0. Now, how do I know? You look at this equation. Alright, from the look, alright, you know that it passed through 0, 0. Why? Okay. Now, your equation of plane, of a line, let's say is, you are more familiar with this. Okay, maybe I just write this. Equals to, now take for example, this is A, B, C plus lambda D, E, F. Okay? Now so I write X, Y, Z will be equals to A plus lambda D, B plus lambda E, C plus lambda F. Okay. Now, if I make lambda the subject of the formula for each of the component, then I have lambda equals to x minus A over D. Then will be equals to y minus D over E. And that is equals to z minus c over f. Alright, so you see that right over here, this is a point ABC is a point that is on the line. Right over here, you find that ABC, they are all 0. Alright, so it passed through 0, 0, 0. The line passed through 0, 0. Now if the line passes through 0, 0, this line, alright, passes through the origin, the plane also has to pass through the origin. So this part is 0, 0, 0. So we don't need to write anything. So you want two vectors that are parallel to the plane. This is one of it. Okay. 8 minus 1, 10. Now the other one will be given by the direction of this vector here. Okay. So the direction vector is 2, 3, and 4. 2, 3, and 4. So this is the vector equation of the plane. Now, if they want it to be in the scalar product form, so now this is a vector that is parallel to the plane, and this is another one. So to get the normal, because the scalar product form, you need the normal. The scalar product form is of this, R dot n equals to D. Okay? Now, what is n? N is the normal to this plane. You can cross any two vectors that are parallel to the plane to get the normal. So this is one vector, this is another one. Okay? So we cross this and the direction vector of the first line, of this line. So n will be equals to 8 minus 1 minus 10 cross 2, 3, 4. Okay. Now you get 26i minus 52j plus 26k. Alright, so in column vector will be 1. I mean, you can simplify the by 26 throughout. Minus 2 and 1. Okay. Now, so your equation will be R dot 1 minus 2, 1 equals to D. Now, you can take any point that is on this plane to dot the unit normal to find D. But actually, you know that it passed through 0, 0, 0. When it passed through 0, 0, 0, your D will be 0. Alright. Now, when the plane passes through the origin, your D is always 0. But if you do not know, you can just take any point on the plane and then you dot, you will still get 0. Now, this is the scalar product form. This one is the vector equation. Now, there's still one form, the Cartesian form. Now, how to get the Cartesian form? Let me use a different color. Maybe I use this color. Okay, to get the Cartesian form is very simple. You just put x, y, z to represent your r. Then you dot the product, so it will be equals to x minus 2y plus z equals to 0. This is the Cartesian form. In the next video, I will be working out this short and yet interesting question. A line from the origin meets these two particular lines at P and Q. You are asked to find vector PQ. I will be working out the full solution. Perhaps you can just try it out first. In any case, I will put the URL link in the description below. We hope to see you again. Have a nice day.